you're going to be looking at 3 different scenarios. Scenario 2, actually it's scenario A, and then on the next page you're going to be looking at scenario B and scenario C. So what you're going to do is you're going to write a function for each scenario, and you're going to write it in factored form and in general form. So you're going to have 2 linear functions for each situation, factored form and general form. Then you're also going to sketch a graph. They have the outline of one for you here, so you're just going to be adding things. And what they particularly want you to make note of is the x-intercept, the y-intercept, and then, of course, you'll have your line on there. And you can use algebra to answer the questions, and you can also check your answers on the graph. So first of all, let's break apart this prompt a little bit. So Carlos prints and sells t-shirts for $14.99 each. So that's a situation I'm thinking off to the side here. If my variable is t, like in all of our examples that we did, each shirt is going to cost $14.99. All right, and then each month, 5 shirts are misprinted and can't be sold. This is kind of like that situation where Marilyn was selling shirts and she was giving 3 away. So at some point in your equation, you're going to represent this idea that you have t-shirts, but 5 of them can't be sold. So they end up losing you money. And then you're asked 2 questions. What are his earnings when he prints 22 shirts in 1 month? Once you have your function set up, say you set it up like this, earnings, and then if you use the variable of t, and then you wrote your function, I'm not going to write it for you, but here's your function, right? You write down your function. What you're going to do to answer this question, what are his earnings when he prints 22 shirts? You're going to calculate what his earnings are when he prints 22 shirts. So you'll use your equation, you'll use your graph to figure out what is the money value, what's the y value, because the y is the money, and the x is the shirts. So you're going to figure out how much money does he earn, what's your y, when shirts equals 22. Then that takes care of this part of the question. But then there's another question. How many t-shirts does he need to sell in order to earn $200? That's the situation where you're going to plug in $200 here. So you'll have your function, and you're going to plug in the $200 right here. And then you'll solve until you get the answer, something, some number, equals t. And that will tell you how many t-shirts Carlos needs to sell in order to earn $200. So this is your second question. And then don't forget to also label somewhere on this line, label your x on this line, label your x-intercept, and then on this line, your y-axis, label your y-intercept, and then wherever your line goes, I'm not drawing it very accurately, but draw your line where it actually goes on this graph. And then it's similar when you look at the next questions. So this one, May is painting and selling vases. This is how much she sells for each one. And each gives you an idea where that number might be in your equation. Each month, she typically breaks 3. It's kind of like giving them away. And then again, you're being asked 2 questions. What are her earnings when she sells 17? And how many does she have to sell to earn $600? So, and then you're also going to label where your x-intercept is and where your y-intercept is, as well as where your graph ends up being. That's very messy. Make sure yours isn't that messy. This one is a little bit different. It's the same in that we know that he sells his toys for $12 each. But this one, he doesn't break any toys or give any toys away, but he is charged a fee of $50 to set up his booth. So this charge this income he gets every time he sells a toy. And this fee he only gets charged once. So think about what that's going to mean for your graph. Where will the y-intercept be? And then don't forget to mark that y-intercept on your graph. Also mark your x-intercept on your graph, as well as putting your line where it actually goes.